uh, the recording starts to record the sound after 5 seconds. Here's the original way which I solved by affine transform. Let's find it here. Then we'll go to canvas, paint components, ordinary things you see. Also for testing I draw two red lines at the cursor. Here's the painting logic. Those are commented out. Simply we get the brushes transform, then create a new transform with that, then we use concatenate, then set transform, drop image, and reset to the brushes transform. Let's go to this transform here. In order to move the image, I wrote those codes, and here's the scale function. It gets the scalar value using this Turner operator. Location is the location of the mouse as a point to the double. We get the inverse of it and store it as the original point. Then once again we apply this scalar to scale. Then we get the new point. Then we also translate the difference between these two to make the zoom happen at the point of the mouse. Let me demonstrate. Right now this is the canvas and this is the image. We can zoom out. Works properly. It zooms out from the mouse and zooms into the mouse. Let's do it again. Now the problem, the artifacts are those. You can see the positions of the pixels shift a bit, especially prominent after 10 times of zoom. Let's look at the value. Also sometimes there is misalignment in this painting. Not right now, but sometimes. My former solution was here. I had to transfer it into a Maven application because I wasn't able to import both of them at the same time for the obvious reasons. Let's go straight into the image pane. Firstly, in here you can see some functions. Those functions came from the limited pane class which I made to handle this problem, which is inside of the lang package. Also here. Which extends the unlimited pane and abstract class. it has the get limit x by pane and get pane x by the limit. Let's understand this one first. If we get the view width and view height, it handles everything related to zoom using these 4 variables and this constant. To get the pane x by vx, we simply reduce. You can see the math behind it. Simple. We also have zoom math here. We just get the view location and zoom into the appropriate pane location. I also tested it here. Let's test it again. Zooms properly. This only adds those 4 functions to simplify the logic and applies them in the appropriate order to achieve the limited pane stuff. And the limited part is the image in simplest forms. Since image is a limited part of the pane, of the unlimited pane, I simply added functionality to handle a limited part of the pane. And image pane here. Wrong image pane. This image pane. I also, if you didn't notice, changed the image pane to optimize a bit. And I actually reduced the update rate for optimization. Still best resource for the original logic lays here. And here. Simply I translated the images coordinates of 0. Here you can see we get the image 0, the image max. Then using those and this draw image function, I derive the image. Back in the days I derived the image like that, or